What's going on, guys? Mr. Jones coming at you once again. Today is probably the last assignment before finals review and finals. So a lot of this should be review. At least the first section, 1 through 12, is review. So I'm not going to spend a lot of time on it, but I do want to talk about it. Okay, so number 1 through 3, in each expression, identify the A, B, and C value. You should automatically know how to do that. I'm not even going to go. Actually, I'll just do a quick one. So it doesn't matter. Here's the equation, negative 2x squared plus 9x minus 6. These ones have a 0 at the end, which normally you have to make them equal 0. And now you just say A is negative 2, B is 9, and C is negative 6. It's as easy as that. Okay, that's 1 through 3. 4 through 12, first of all, I want you to skip number 5. Okay, so skip number 5, and all of these are, you're going to write them in factored form. So if you just saw one like this, x squared plus 5x plus 6, for example, you would know that x plus 2 times x plus 3 is the factored form of this. So that is problems 4 through 12. Go ahead and skip number 5. All right, on this next section, it says you're going to have an exponential form and you're going to have radical form. And so it reminds you right up here up top how to change from a fractional exponent to a radical. I also gave you notes on that, last week it looks like. So you should definitely have in your notes how to convert. Number 13 is pretty simple. Number 14 is pretty simple, but once you get into multiple, students usually get a little bit confused. So let's just do an example really quick of what number 15 would look like. Pretend it said, I don't know, the fourth root of 2 to the 6 times 4 to the 2nd. Okay. The first thing you'd want to do is realize that these bases are different, so you can't combine them at all. So pretty much you could rewrite this, if you want to think of it that way, as the fourth root of 2 to the 6th times the fourth root of 4 squared. All I did was just separate these two things into their own radicals, and now we could rewrite this. So this one turns into 2 to the 6th fourth power times 4 to the 2/4 power. And then you could just simplify and call that 2 to the 3/2 power times 4 to the 1/2 power. Okay? And so now we have, this is my answer for that one. And you can see the answer looks similar to number 16. Okay, number 16 is the exact same thing, but just opposite. So if you have different exponents, just see what that would look like. Make them separately and then see if you can combine them. Okay, so if you can combine them, cool, but you can't, if they don't have the same base, you can't really combine them. All right, although if you did see this, you can put them both under the same radical because they have the same radical. All right, the next section, number 17 is going to be very similar. That's exactly the same thing as number 15. You don't have a multiplication sign in between them, but it's the exact same thing. Same thing for number 18. 18 is a little bit different because you actually have a number under there. So let me just do one similar. I'll pretend it's a square root. We'll call it 8a to the 4th b squared. And then we're just going to simplify. Okay, so you're going to simplify numbers and numbers and letters and letters. Okay, the first thing you can think of is you can change a to the 4th power. That's the square root, so you have 4 halves, right? And you have b to the 2 halves. So those are fractional exponents of each one of those. The square root of 8, you can actually make that the 1/2 power, okay, times 8 to the 1/2 power, okay? 8 to the 1/2 power. And now you can actually combine all of these because you notice they all have the same root. They're all 2. Actually, we're not going into radical form. We're going into fractional exponent form. So we're actually done. All we have to do is simplify our exponent. So 4 over 2 is 2. 2 over 2 is 1. And 1/2 is just 1/2. So I'm going to go ahead and put a 1/2 there. and we're done. Okay, so you could simplify. You actually do this division. 4 divided by 2 is 2. 2 divided by 2 is 1, and so forth. The scary one looks like number 19. I'm going to do one similar. I'm not going to do a fifth root. I'll just do a square root, I guess. So we'll say 4x squared y to the fourth. And I'll say 16 y to the 8th power. All right, so now that I got this written out, we're going to go ahead. We have to use two different methods. We have to use rules of exponents, and then we also have to simplify radicals and turn it into exponential form. So forget about the radical for a second. Okay, what if it just said 4x squared y to the fourth over 16 y to the 8th? Okay, rules of exponents says that we could actually subtract our exponents if we have the same base. Okay, first of all, simplify 4 over 16 as 1 over 4. 4/16 is the same as 1/4. X squared stays the same because there's nothing on the bottom down here. So you don't actually change that. And then y to the fourth and y to the 8th, it turns into a y to the negative fourth because 4 minus 8 is negative 4. Okay, so far we have this. All we want to do is simplify that. The 1 on the top can go away because you're just multiplying. Okay, x squared on top, and we got a 4 on bottom. The only thing I don't like is this negative exponent. So you're going to put it on the bottom and make it positive. Okay, so this is the simplified version, all this in blue, of everything under the radical. The only thing now we have to worry about is actually simplifying the radical. Okay, simplifying the radical. Okay. So just be aware that this is the same thing as having a radical on top and a radical on bottom. Okay. So you can separate them. It's the exact same thing. Okay. It's the exact same thing. In fact, the rule is, you might want to write this rule. I'll put the rule over here really quick. Here's the rule for radicals. If you have something like this, it's the same as this. Okay, so these are exactly the same. You might want to put this in your composition book because it's a lot easier to deal with this side over here, generally speaking. Okay, so now that we know that those two are the same thing, I separated them, as you can see over here on the left. And now I'm going to go ahead and simplify my radicals. The square root of x squared is just x, so I'm left with an x on top. And the square root of 4 is 2. And the square root of y squared is y. Okay, so all I did was actually square root them. You could factor tree them if you wish. But square rooting and squares cancel each other out. And I know the square root of 4 is 2. So this would have been my final answer for the original problem. All right, other than that, that's all we're doing for this worksheet. So let's move along. The other worksheet I think I'm going to give you is, because this one's a little bit short, the only long part's kind of 13 through 20, but it's just, and you're also skipping 21 and 22 for now, okay? But this is a pretty short worksheet, so I'm also going to give you some more practice on radicals, simplifying radicals. Okay, this next thing I'm going to show you is like a simplifying radicals part 2. We've all simplified stuff like this now where I can turn that into a factor tree. And then I can turn this into 2 square roots of 3. Right? So we should be familiar with that from the last video. But what if I threw some numbers in there, right? How does an x squared or an x cubed affected by this method? So let's check it out. The first thing I want to talk about, what we already talked about last problem, which is this, that the square root of x squared equals x, okay? Or the cube root of x to the third equals x. So if your exponent and your root, remember this is indivisible too, is the same, then all you're left with is your base, right? So just keep that in mind. Another thing to think about is this. What if I just told you, hey, simplify this using a factor tree? Okay, we already know the answer. Let's go ahead and make it into a factor tree. Okay, so what two things multiplied together give you x squared? x, and x, right? And since we know we're dealing with the square root, you can cross off each x and pull it out of the radical. And there's nothing else left over, so there's nothing else left under the radical sign. What if I said the square root of x to the third power? Okay, same thing. You could do a factor tree if you want. You could say x times x squared, and then you can come down here and you can say x times x. Okay, and then you realize, okay, this cancels out. Okay, I have a pair of x's, pull it out. I have one x left over, leave it in, and then this will be my answer, right? So one out, one in because of how many pairs I have. Okay, the trick is it's really simpler than that. If I said, what's the square root of x to the 8th power? You know that because this number that I put a circle around is an invisible 2, that you're going to have to ask yourself, how many pairs of x's am I going to get out of this? Well, I have 8 x's, so you can think of this as x times 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 x. This is how many x's I have if I was to make a factor tree. Okay, so how many pairs would you have? 4 pairs, right? 1 pair, 2 pair, 3 pairs, 4 pairs. That's what goes on the outside of the radical. Okay, what's left over is nothing because it's an even, my exponent is even, therefore I'm going to be able to divide by 2 an even number of times. Okay, let's say that I did the square root of x to the 9th. You would still say, okay, I'm going to pull out 4 pairs. So on the outside, I'm going to have x to the 4th. But I'm going to have 1 left over because I'm going to have 9 x's. So that would be my answer instead. Okay? So you have 1 left over and 4 on the outside, x to the 4th on the outside, and 1 left on the inside. All right, last thing I want to show you really fast, and this video is long enough, is let's say I did something like this. I'll do 2 of them. Let's say we did 8x to the 3rd power, and I want to simplify this. Okay? First and foremost, I like to tell the students, go ahead and put the radical in your answer. Okay. Now let's go ahead and factor tree the 8, and we're also going to factor tree the x to the 3rd, and then we'll put both of our answers together. Okay. So this one's 4 and 2, 2 and 2, and if you cross these out, I'm going to pull a 2 out, and I'm going to leave a 2 in. Okay. Come to this one, I'm going to have an x, an x, and an x. We know it's 3 x's without even making the factor tree. Okay, pull 1 out, leave 1 in. And this is your entire answer, right? So you do numbers separate from letters, and now we have simplified the radical even with letters inside. Okay. All right, I want to go ahead and stop it there, guys. Go ahead and get to work. Have a great day.